Hello, lovely people. So in this video, we're going to talk about fitting the S-curve with seasonality. What is seasonality? First of all, let me just introduce a little bit about time series. So we have time. Okay, so let's say that we have, of course, this data that is time-based, just like our data right now. Because we have the x-axis is nothing but time, right? So when we have a data that has the time on the x-axis, we expect the following two very important behaviors. First behavior I'm going to talk about is a trend. What is a trend? A trend is usually a linear line. A trend could be understood as a linear line. For example, the sales is going up over time. All right, good. So you can actually fit a linear line through this curve, and will be an increasing trend. So the trend of the data will be understood as an increasing trend. Or the trend could be decreasing, so the data may be going up and down, whatever it is, the sales, and then you can fit a line through it, and the line is linear through it, and that trend will be decreasing. All right, so the first thing is find a base for that line, which is this line that cuts through the average. Isn't it linear regression? We always talked about it as being a weighted average almost. So there are the betas, the coefficients are like a weights on the effect of the x on the y. So it's like building a base. So this base is how much is this line away, this black line. How is this black line away from x? We can find out how much is it away upper-wise, vertical-wise. How much is it away from the x? This is how I like to explain it. This is my own explanation, actually. This is how I explain it to myself. So I want to know how far are you as a line away from me with respect to the x-axis. So with respect to the x-axis, I would like to know here, are you increasing? Or are you decreasing? Or what is the deal with you, really? So this is the trend. So the trend is a linear line fitted through the line, and we want to know if this line is going up over time or if the line is going down over time. Now, as you have probably noticed, the lines that I drew have a little zigzaggy, like it's going up and down. So for example, this is the year 1. And this is year 2, the year 1, and this is year 3, okay? And this is starting from January until December, okay? It's starting from April. Let's do it the Japanese way. So from spring to winter. So April, May, June, then the sales are like that. Then comes summer, July, August, September. Then goes down, then again goes up during Christmas. So it is like that. This means that, and then over the years it's like this. Then it goes up and up again. So first of all, in terms of a trend, what is the trend? I draw a linear line like this with my beautiful eyes, your beautiful eyes, not mine, and then you will find out it is increasing as x increasing. So that is the trend. So the trend is increasing. Okay. So it is like having, you want to inspect the Christmas decoration that you hanged in a trendy way from corner to another corner on the ceiling, and you hanged it, of course, increasing because it's from the, let's say, half the height of the room all the way to the center on top on the ceiling. So the decoration is actually hanging in an increasing manner. This is the trend. If you want to inspect the decoration, you will take it down. And you want to inspect it. Let's imagine that you are holding it with your both arms from one end to another. Let's say that. Are you going to hold it and inspect it, keeping the trend, keeping the decoration, the Christmas decoration hanging in such a way it's increasing from the left arm to the right arm? Are you imagining what I'm talking about? No, you're going to put it on a straight table. Right? You're going to put it on a nice straight table and start inspecting the decoration if you want to inspect it. So let's imagine this kind of Christmas decoration is the timeline. And the timeline is hanging in an increasing manner from the floor or any halfway through the room, the corner of the room, all the way to the center of the ceiling, let's say. So it is increasing, yeah? When you want to inspect it, are you going to keep your arms stiffed, keeping the trend? No. When you want to inspect the Christmas decoration, you're going to put it on a table, flat. So this is the idea of inspecting or analyzing the time series analysis. First of all, you need to strip out the trend. So you find the trend and then you subtract it from it. You strip it out. Cool? Isn't this what you've done in statistics too? The teacher used to tell you we need to strip out the trend. Why? Imagine yourself putting it in a Christmas decoration, yeah? Are you going to inspect it like that? No, you're going to put it on a flat table. And this is why I told you this is how far away is it from the table, from the horizontal plane. Okay, I'm sorry, it's a very naive explanation, but I hope it works. Now, lovelies, all right, let's talk about these little zigzaggies going up and down and all around. All right, what are these? This tells me that there is a cycle of increase here in the summer, and another cycle of increase again during Christmas, let's say. Yeah? So there are two cycles, a cycle. First cycle is during summer, and second cycle is during winter. So basically, our time horizon is no longer the year. This is you as a human being. You as a human being, tell your story as you wish. You're telling your story that you have year 1, year 2, year 3. Data lives in the spatial space. Data doesn't know year 1, year 2, year 3. This is you on planet Earth. Year 1, year 2, year 3. I am data. I say I am showing you that I have cycle 1, cycle 2, cycle 3, cycle 4, cycle 5, cycle 6, cycle infinity. So now let's take another color here. So we have cycle 1, cycle 2, cycle 3, cycle 4, cycle 5, cycle 6. So this is what we call it seasonality, really. So am I going to talk about the trend in this lecture? No, because we're talking about seasonality. But I just wanted to remind you of what you guys took. So now the data doesn't know. Data doesn't know year 1, year 2, year 3. The data knows seasonality, knows the behavior. So maybe there's only one. Maybe it will have one circle like that and then down, up and down. It's also two circles. One circle you're going up, one circle you're going down. I don't like this circle. Nobody likes this circle when it sails. Then you're going up, then you're going down. You're going up, then you're going down. And just in my case, I put it, actually this is not two circles. If you want the truth, it is 4 circles. This is down, up, up. I was mistaken, you see. So the kind of circles, this is to the, you either let the data tell you or either you as an analyst force it. But you should listen to the data. You should listen to the data, guys. So actually, I was mistaken. Down, up, down, up, down, up, down, up, down, up, down, up. So actually we have 4 cycles in 1 year. It just happened. I just didn't want to, you know why I said 2 at the very beginning? I just didn't want you to think, because we have 4 seasons, reality, 4 seasons, then we have 4 cycles. It's not that. So I should have probably, this spontaneous, I just done it right now spontaneously, but I should have done something like that, down, up, down, and it's increasing also, there's a trend. So we can say this one cycle, this is the second cycle in within the year. One cycle, second cycle. I hope you understand what I'm talking about, even though it looks very scary now, the slide. But the idea of a cycle is that it's not necessarily because we have 4 seasons in the year, we definitely will have 4 cycles for each year. This is not true. And seasonality has nothing to do with the cycles. All right, lovely people, fitting the S-curve with seasonality. If the logistic curve is fitted to quarterly or monthly data. So let's say that you want to fit the seasonality. There is a seasonality for each month. Oh, what are the odds? What are the odds that every month you have a certain cycle? Well, maybe we'll see. What's you going? I don't know how this. Sorry, blah, 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 blah. But it's very difficult. But let's say that you have a cycle, a very unique cycle, every month of the year. Then you have how many cycles? 12 cycles. If you have different cycles, meaning you have fitted the curve quarterly, then how many quarters do you have in the year? 4 quarters. So basically you will have 4 different cycles or 4 different time periods. So the seasonality of sales must be incorporated in the estimation process. Let's see, how do we illustrate this idea? We illustrate this idea by visiting the iPod seasonal.excel. All right, take a look. Discard. Let's take a look at this file. Of course, this file is available here, guys, for you on Moodle. It's available where? Let me make sure that I have it there. This is the Cell Pearl. We were supposed to cover it last. Do we have it? Yes, this is the iPod seasonal. All right, so let's do this. Let's do it together. And now we are going to take a look at here, students. So this is the solution. Please don't take a look at it for now. So what's the difference here? The difference is that we, for each year here, right in front of you, let's show you. For each year, we said we're going to fit it quarterly. So we have 4 different cycles, as I showed you earlier, maybe down, up again. Usually the cycles are down in certain months and up in summer and in Christmas time. Or anyway. So we have 4 different periods for each year, but we started with one in the last quarter of year 2002. So this is quarter 4. So this is quarter 4 of year 2002. So even if it's a quarter 4, the quarter here number is just the serial number for the number of periods. So this is not quarter number per se. This is, I'm going to put it as the number of periods. So this is the number of periods. I like to explain it this way, like with all respect to the author, but this is a confusion. He puts quarter number and then he puts quarter. I understand he's saying that this is the number, the total number of quarters, but let's say the total number of periods on that line, and this is the quarter. So this is quarter 4, and this is the first period that we are working with. The year 2003 has 4 quarters. Every year has 4 quarters. But here we are going to have a serial number of the number of periods. And this is the sales, the cumulative sales here, you can see it. And not cumulative sales, but this is the sales per period, sorry. And this is the population. Over here, we're gonna find the sales per 100 population. So it is gonna be the, sorry, did I put the population first? Here, sales. Sales over this population over 100. So this will be, as you can see, the sales per 100. And then, sorry, excuse me. I think the exercise is up to here. I added these guys for the sake of future prediction, because I want to show you future predictions. All right, so now let's talk about how we are going to incorporate the seasonality. How are we going to incorporate the seasonality? If the function that we are using is like this, and we don't have seasonality in it, how are we going to incorporate these different seasons or cycles, 1, 2, 3, 4 cycles each year? So we have 4 different cycles. All right, and they are again repeating themselves over the years. So this is very important, that the cycles of year 1 are copied again for cycles of year 2, but maybe there's a trend. They are a little bit higher or a little bit lower, depending on the trend, but they are exactly the same. Low, up, low, up, low, up, low, up, low, up, low, up, or up, down, up, down, up, down, up, down, depending, yeah? So, okay, so let's take a look here. How are we going to use the prediction with this season, with this period? So basically what we are going to do, as you can see here, this is just an explanation of the seasonality. What we are going to do, guys, is we are going to maybe I did something here. I think per 100 people, we don't divide over the number over 100. Aha. So it's going to be, this is the sales over population, and this should be 100 times. So it's going to be like that. Is it the same? It is the same. Do you see? I did it that sales over, but why did I put the sales over population over 100? It shouldn't be like this. So this is sales over a population, and then here 100 times. It's going to give us the same same thing. It's going to give us the same. So you can see that if you done it my way, your understanding, or done it like the book, it's all the same. Okay. So now let's take a look at what we've done really. So what we've done really is here, we're going to put L over 1 plus A exponent minus B times the time, the period, times a horizontal lookup, so that we can look up the time period here. Of course, we have a time period, as you can see, I told you this, the cycle is repeated, and this is why we need the quarter. So which cycle are you? So that I can pull out the number from here. So you are going to multiply it by the value of the corresponding cycle. So basically what you need to do is you need to find out this row, this corresponding row, which cycle they belong to. Cycle 1, cycle 2, cycle 3. Are you in cycle 4? So that you can look it up and pull out the number, the corresponding number. So let's do it together. So if this is going to be L, yeah, so this is L. I think I have the names here. Yeah, so I can't name it over here because of the solution. So we have L, and please, so we have L over 1 plus exponent of minus B. Oh, where's A? I always forget A. Please don't do like me. Don't you forget A. Come back again to A. It's easier to come back again to A because you put it in a nice order. L, A, B. So here is B, right, guys? And let's freeze it. B times what, guys? Times this periods. This is the T that we're talking about in terms of the periods. Be careful. And then close this, make sure that this is all closed. And I would say I will multiply this whole thing with the H lookup as I showed you here earlier. So this whole formula, L time over this multiplied when you closing everything, this is multiplied by this H lookup. So let's take a look what's going to happen here. So over here multiplied by the horizontal lookup because we have a horizontal table, but the lookup value is the cycle here. So are we in cycle 4? Yes, we are in cycle 4. So for this range, please forget about the average. Now, for this range, and let's just freeze this range, give me the value that corresponds to this C5, which is the quarter 4, in row 2. Okay, and this is it. Now we are ready to rock and roll out. Make sure that the values are fixed. And now you just need to find out the squared error. So the squared error is going to be the actual here minus the predicted over here, and all to the power of 2. All right. And then did I have this also point here? Yes. So we have the actual minus the predicted to the power of 2, and then just have it there, and this is the sum of all these squared errors. Okay, and now what's next? What's next is running solver. So do I have a solver over here? Yes, I do, and here is what we've got. Let's see how we put the solver values based on the author. Author sometimes exaggerates the limits, but it's okay. It doesn't matter as long as it's giving us the right answer. Oh, I don't have it. Okay, good, better. So now we can put it together. So the first thing is the sum of squared errors. This is what I would like to minimize by changing all these values as you can see over here. But now I'm going to set up certain boundaries and restrictions. The first set of restrictions that I want to talk about, as you can see in this slide, is the restrictions on the L, A, and B. So from, as you can see here, from G to I, L, A, and B. So these restrictions, as we've done in earlier video, they're going to be G to I, which is L, A, and B. They're going to be greater than or equal. Actually, it shouldn't be greater than or equal to 0. It should be 0.01. Even in the previous example, I don't know why we put greater than or equal to 0. Because otherwise it's going to give me a 0, and I don't want it to be a 0. So if you are getting problems with that, please try 0.01. Yeah, if you're getting zeros in there, please try 0.01 as the least minimum, but you shouldn't get a 0 really. So it should be greater than or equal to 0.01, and then also it is less than or equal 1,000. And then the cycles here, the 4 cycles, we definitely have 1 to less than or equal to Y5. It should be less than or equal to 4, in fact. And then it should be greater than or equal to 0.1. It shouldn't be 0, so. And then, in fact, we have N. N is the average, and this N is supposed to be 1. So you need to add this N. Let me show you what I've done with this. This N is supposed to be the average of all this is supposed to be 1. And this is why I am not really worried about less than or equal. Instead of less than or equal to 5 here, please try less than or equal to 4, because we have 4 different cycles. So this is going to be the answer, and I put the answer for you here. So the answer, as you can see here, is the average. It shouldn't be like, it's not a big deal if it's, yeah, the seasonality here, as you can see, the values here are even below 1, most of them. This is greater than 1. So it doesn't really matter if you put it less than or equal to 5 or less than or equal to 4. But, well, try it and you will see. Anyway, now some of you might say, why is it 5 or 4? I personally will put it less than or equal to 4 because we have 1, 2, 3, 4. Yeah? If you put it, if one of them is 5, let's say, if one of them is 5, what would be the other values so that the average is 1? You know, these values will be so small, so little, so that the average will be 1. And this is definitely not what we're looking for. So there is a way to find out the kind of the value of 4 and 5, but because you didn't take time series analysis, I'm just not going to ask you. I'm going to give you the value 4 or 5. And if you studied time series analysis, you will be able to reason that much more, much better. All right, so now that you ran the analysis and you got the values here, now I would like, and we have the data up until 2006, right? We have the data here up until 2006, the second quarter. So let's say that I already knew the values here. Yeah. So now I would like to make predictions. So here is the prediction. So I'm going to just take this, but it's not working. Why is that so? Because I don't have the, this is the actual, actually, this is not the prediction. This is the prediction, guys. I'm sorry, because I saw SSE here, I got mistaken. So these are the predictions. So this is what I'm trying to do here. So these are, this is up to where we have the values. So the values is up to here. And now these are the predictions. So this is the prediction. As you can see, we have a circle here, up, down, up. So you see down, up, down, up, down, up. So the circle is a little bit exaggerated. Something is up with the, I didn't agree with this 5 that he put. I feel like there's quite an exaggeration. Here is up, down, down. But this up is quite exaggerated. Why? Because he put it too high, I think. So if you want to, oh, but this is actually the correct one. This is the actual in blue. So the actual in blue was very high. So you can see that the actual in blue was very high. So this is why this is also high. So it is actually a very good prediction. So we did a very good job because you can see the blue here. So over here, if I want to zoom, there's a blue line here underneath the red. Up to here we are done with the actual. And then the predicted has also given a very good prediction based on the previous year's corresponding cycle. So that's really good, isn't it? So with this, I'm gonna end my explanation. Please make sure that you understand why we are doing this data up to here. So this data is provided to us up to this level. And this is one of the things that is that the book doesn't show. Where is the prediction? It's not only prediction over here, but prediction of the future. And as you can see here, the prediction of the future has mimicked the previous cycle, the last year's cycle. So we are doing a very good job mimicking the previous cycle or predicting the future based on the most and the recent behavior of our sales. Thank you so much, and I will see you on Tuesday. That would be, unfortunately, our last class for this semester. I'm going to say some words of goodbye, take some pictures on Zoom so that we can keep them for memory when we had all this Zoom the classes. So please make sure that you are ready to turn on your videos so that we can take some nice pictures of ourselves to keep it for memory. I'm gonna put it on Moodle so that you guys can keep it. If you don't want to show your picture for some reason, then don't turn on the video, but I beg you to just kind of be ready to turn on the video so that we can take a nice picture together for memory. Thank you so much, guys. I'll see you again on Tuesday.